What's up, everybody? Happy, what's today? Monday. Started the brand new week. Sorry, I'm a little bit late. You all already know that on Mondays, I have to do a little bit of I have a call right before this every single Monday, and I ran a little bit over today. So good to see you. Hope everyone's doing well. Penguin Airlines, of course, you are number one. Let me make sure. Can y'all hear me today? All right, good. You can hear me. The music might be a little bit loud. Okay. All right. But I can see that you can hear it. So we're not going to go 3 hours today without any music. How's everyone doing? What's up, Luke? Good to see you. Omar, good to see you again. Laylar, good to see you as well. Burning JC, welcome. Hikaroshi, nice to see you. Dorothy, good to see you. Thank you so much for the tier 1. Hope everything is going well. I appreciate it. I just got on the hat. It's cold. It's cold. It snowed again here in Maryland. Another couple inches, but I mean, it dusted this morning. I mean, it was sticking for sure. Not crazy, but it is a little cool. So just gotta make sure you're warm, make sure you don't catch a cold. What's up, Aya? How you doing today? Yeah, we are in container week. We are in the final week, which is interesting. I have some stuff coming out for you guys on how to, because I didn't drop all the stuff that I was supposed to drop. There's going to be a package for you all to do all of the quizzes and assignments and things in your own time, and a good way for us to verify them. The good thing is that we actually may go forward with utilizing this as a part of all the boot camps in this kind of packaged up version, and we may give you the package right up front so that everybody has everything right in the beginning. So don't sweat it. I've got a number of questions about it, but yeah. So the drive issue, by the way, motherboard. So I actually am pretty sure this motherboard has been the root cause of all of my issues, or that motherboard had been the root cause of all of my issues. So RMA'd, but have another one. It wasn't the drive. Pulled the drive, was able to boot the drive in another computer, was also able to get it to read and everything off of an external enclosure. I think it was that M.2 port, but I think there were some other issues with the Mobo period, which I think led to previous issues as well. We'll see, if we continue to have other issues, then thank you, baby. Our problem, we might have to go pre-built or something. I'm not sure. Dorothy, I was just about to ask about that. That is amazing. First off, let them know we said congratulations. That's dope. Hopefully everything goes fine with the clearance process. I know that can be an excruciating process sometimes, but that is awesome. I'm really, 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 really glad to hear that. For sure, that's dope. Of the East Coast, so I don't even remember the horror sometimes. Yeah, and I mean, not bad at all. Like the snow, not terrible. There has been snow on the ground for much too long. Like I can't remember the last time I could just clearly see the grass, to be honest. But I like the snow. I generally like the snow. When you used to get out of school or get out of work for it, but not so much the case. Finally sunny in Texas, snow's all gone. That's great. I'm really, really glad to hear that. I mean, the Texas situation, wild. I understand the implications of it, but it's another reminder to. I think what I've started to learn about a lot of these things is just for my own sake is being familiar with the way that things work. I think one of the most interesting things about the whole situation is learning how things work in Texas and how they work differently, and there are pros and cons to all of those things. But now I'm just a little more interested in the way things work, and especially in the places that I'm going to live. I'm now diving into what's going on in Maryland a little bit more, so I understand what's happening. Let me try. Frogelberts, thank you so much for the tier 1 sub, 2 months. That's amazing. 2 months in advance. That's amazing. I appreciate that. Thank you so much. Paperwork for days. Yeah, it is. It definitely is. Clocked out of a terribly long day where everything was cluttered and went wrong. Abyss, I'm very, very sorry to hear about that. Hopefully today we can, provide a little positivity, a little bit of fun. It sucks. It definitely sucks. You're gonna have days like that. But tomorrow is a new day. Hopefully everything tomorrow will go right, What do we make up for the Ansible course? So, no, we did not do the makeup because I just got everything up and running. That is a good question. That's a really good question. I'm trying to figure out when to do it. The reason why it's going to be tough to figure out when to do it is because, so it might have to be Sunday morning. The reason why is we have a full week of streaming. Saturday, there's an event that I was trying to put out some stuff for today, but we were still trying to confirm personnel. But there is a special event on Saturday, a special kind of discussion / panel thing going on Saturday. And Sunday, it probably had to be Sunday mornings. Sunday is also our exciting Twitch baby shower. So if anyone wants to come through to that, I'll find the little advert we made for it just for fun. But yeah, so on Saturday will be particularly around leadership in tech. So we're gonna be talking to CEOs and directors, and we're gonna be having discussions of people who've built large organizations and who've led in the tech industry. We're gonna be talking about a lot of different things, not just around entrepreneurship and leadership. It's more so about technical mentorship and growth and kind of understanding how to navigate the industry. You know, we usually do something like this at the very end of all the boot camps anyway, but it's going to be, there's some big time, there's some heavy hitters for sure on this panel. So it should be pretty exciting. Definitely should be pretty exciting. And so it'll probably have to be Sunday morning. I'm still trying to figure it out now, but tentatively Sunday morning for that. We will not skip it. We definitely will not skip it. Worst comes to worst, it'll be Monday of next week. Worst comes to worst, but that's supposed to be something different. But we'll see. We'll figure it out. I was gonna call my boss and I was like, did I just get rate limited by HashiCorp? Sounds correct. Yeah, you know, there we go. Come on through. Saturday at 2 p.m. I mean, Sunday at 2 p.m. I think that's what we're gonna do. It's gonna be fun. I'm telling y'all, it's gonna be a very exciting time. It is going to be us entertaining you all. We're coming to entertain. We really just want to have fun. Me and my wife just want to have fun in this process, and we're gonna go through all of the old wives' tales and allow you to do some guessing to figure out if you think it's gonna be a boy or a girl based on all of the, all those wives' tales. We got some pre-recorded videos and stuff. We'll let you all guess and figure out what you think it is, and then we'll let you know at the end. I'm not sure we're gonna give out any names or anything like that, but yeah. HashiCorp had an outage on Terraform providers today for about 30 to 45 minutes. That's interesting. So that is this is a really good thing. Not a good thing. Abyss, I'm wondering, when you said they had an outage on Terraform providers, does that mean they had an error on pulling provider packages like down from the registry? Did they have a registry outage? I thought this was the last week. It is the last week. Yeah, so Burning JC, likely, I haven't put out anything because I'm still trying to figure it out. I might, because of the nature of, we're almost on baby watch right now. I was gonna start Tracks up on Monday. So Tracks is the Git excursion. So yes, I'm probably gonna do Tracks first. Tracks is definitely gonna be one of the first ones that's done. I'm trying to figure out what days. I'm not gonna be streaming 6 days a week for the month of March. Probably streaming 3 to 4 days a week just for the month of March before we start up the new boot camps again in April, the next level of boot camps in April. But Tracks for sure, and probably along with Tracks, probably Waddle, which is the Linux one, will probably be the first two that go. And then we'll probably do what we're gonna learn tonight, which is containers. We'll probably hop into Docker. And maybe I have a couple of other new ones that I might want to try, but I'll definitely let you all know about that. But yeah, pulling the AWS providers from the release page, I guess the registry. Yeah, very interesting, but not the modules. That's very interesting. That's very interesting. It also, things like that are also why I find why understanding pipelining and understanding what options you have in pipelining is important. That's pretty interesting. That's very, very interesting. And determining, what during that process, what layers you can cache. Cause I probably wouldn't cache those things, but just a very interesting breakdown. I really want to, outage report perfect. I really want that. So one thing, since this is pipelines, this information is super pertinent to you all. There's a couple things I'm trying to work out right now. I really like things specifically like this, like this outage report. One of the most valuable things to you all wanting to become DevOps engineers, site reliability engineers, dealing with infrastructure, is to get some insight into things like this. And I'm trying to create a forum or a way, I don't know if it's gonna be on YouTube or here or both, of where companies can start to go through these things and break down these things. We're attempting to set one up right now with digital transformation with a project that I was on. I've talked about it a number of times, but I'm trying to set it up now where we can come on here and we can talk about where things were, how they started, draw you all infrastructure diagrams, give you context, tell you why we made certain decisions, and then walk you through the process of how things were structured, why we moved from here to here and then here to here, the incremental steps that we're taking, to really let you hear about these journeys and understand what kind of things can go wrong and why all of the best practices and pros everyone tells you to do, why that doesn't always make sense and why you can't always do the ideal thing. And I think it'll be very valuable for you to hear things like that. But I would also love for companies when they had outages like this to want to come to a place like this and talk about it and to help people understand and to talk through it. And so I don't know, I think it'll be cool. I think people don't talk about, these aren't failures, but the failures enough. This is where you learn the most and stuff like this. It's pretty interesting. So dope. Let's see. Just found out your stream. I see part 15 to 16. The other parts, some of them are here on Twitch. Because we got partnered, so the last month or so should be here on Twitch. I don't know about the ones before that. They're all on YouTube though. If you hit exclamation point YouTube, they are there. Everything's uploaded, and most of the data is in. They will go live tonight. All the other videos will go live on YouTube tonight. If you've been waiting for them, for sure tonight they'll all go live. The only thing I was waiting for is for some of them had copyright claims, and I was waiting to get those cleared out before I release them. And so they're all good to go. I think I have to add data for 1 or 2 more. Martini Soft, thank you so much for the raid. Welcome to the channel. Hope you had a great stream. Welcome. All right. I don't know any HashiCorp SREs, but we can just, if we all work together on Twitter or something, we can ping. I've seen Mitchell Hashimoto, I'm pretty sure it's his last name. I've seen him hop into streams especially when people were going over, when they launched, what was the last 2 products? Boundary and Waypoint. I think it's Waypoint. He hopped into a couple streams when people were going over them. So maybe, they seem like they'll be pretty interested in doing so. What's happening, Andy Shen? Good to see you. We're streaming Docker builds. Amazing. Excellent. So this is Container Week. That's a good thing to bring up. This is Container Week, and containers are super duper important. They're very, very important. It really has changed the way that we design, manage, and the way we design, deploy, and manage applications, especially at scale. And so it's really, really going to be good to understand what Docker is and what you can do with it, and kind of understand container technology. And that's what we're going to be diving into all week. Tonight, we will learn about what Docker is. We'll get it installed. We'll hop in. We'll get some containers running. We're going to understand the basics of it tonight. Because this week is not designed for you to become a Docker Pro, on Wednesday, we are going to build stuff with that. We're going to basically run a custom piece of application, a custom setup with a bunch of different applications using Docker, rather than diving into the nitty gritty of all of it. That is what that's what the contained excursion is for, and the contained excursion will run sometime this March. So March is next week. It will run during that time. So if you want to dive deeper, the contained course has changed. So if you did it before, it has changed from what it was. It's been condensed in the front end, and it's allowed for us to do some more stuff on the back end of it. It is 6-part series in the Docker. So the first 3.5, you'll be diving into all the Docker concepts, and we'll be building stuff, but we're gonna have a lot of fun with it in the last 2.5. All right. So let's hop into our stuff tonight. Let me get your classroom set up, because I've been off my game for sure. Let's go ahead and let's get a topic set up. And today is day Diez, once, doce, trece, catorce. I don't know how to spell this, but you know, that's got to be wrong. Whatever. I'll figure out how to say. I'll figure out how to. I don't know. That's supposed to be 14. Actually, you know what? We have Google. And Spanish. Oh, your boy. I told you this is why you can't be afraid to take some shots in the dark. Sometimes you just got to throw it out there, see what sticks. Catorce, got it right. And today we're only going to be doing the first two materials from. Let's do slides here. It's a little loud. And we'll put it in Catorce, and we'll do the first two from contain, which I did touch, so they should be right up front here. Decoded, scroll up, intro to the cloud. Let's see. What are we looking for? We are looking for the ones from contained, and contained part 1 sounds good, and contained part 2. Those are the two that we're gonna hop into today. And again, it's gonna give us just enough to get all the terminology down, to know what's going on, and then we will, we'll get going. So I'll post those. Those are available, and we'll click into one, and I'll give you the link. Anyone with the link? Let's remove this link. Copy link. Here we go. There you go. Now you can get into there. And you can get all of the sweet Docker container goodness that we're about to get tonight, because again, Docker is interesting. Containers, understanding containers. Again, my recommendation for what you should learn. People always ask me, if you want a job, is cloud and containers. Right now, that's my thing. Cloud and containers. I recommend that often. What's weird about it is I haven't been able to do Docker super big. I've done a ton with Docker, but now, even though it's huge, everyone's on the container train. I'm on the serverless train. So like everything I build nowadays, I'm like, man, just come on, man, let's just do serverless instead. So it's always, I always feel like a trader. I think whenever we start talking about Docker and we start diving into it, I always feel like a trader. Are containers Linux only? No, they're not Linux only. We'll talk about that. We'll talk about that for sure. They are not Linux only, but kinda Linux only. But Docker does work on Windows as well. And Mac. We'll talk about LXC tonight as well. We will talk about LXC, and yes, Windows containers they work. Let's just say that they work. So let's get started on it. If your thing was containers and now it's serverless, are you a big fan of Fargate? Yeah, I mean, yes. So good question. No, I'm not purely. I am a fan of Fargate for what it is as a technology. I don't utilize it much because of the cost. Fargate is a bit expensive, and I am comfortable enough. I'm comfortable with containers, so I'm fine managing it on instances if I need to. Yeah, I'm fine with the management of containers, but I understand the appeal of Fargate. If I was working for an organization who was using containers, I would push Fargate if it made sense. If they had the budget for Fargate, I would push Fargate, 100%. Not having to worry about instances is great. Just running the container is phenomenal. But again, it's expensive. If you're doing it yourself, it's expensive. Okay, it's definitely expensive. You can run Docker on WSL. That is very, very true. So I found it to be mostly good with Docker. The only things I've seen that are weird are with, I've seen some issues running Mongo and a few other things like, they seem to be pretty small. There's some workarounds on it. You might have to do like host networking for some reason for some of these things, but yeah. If you have more money than time, there we go. But that yes, 100%. I agree. If you got the money, I think it's good, but if not, it can be quite expensive. So that everyone is on the same page as us, so that everyone understands what we are talking about, let's dive into Docker. This is not contained Docker deep dive, but tonight we're going to be learning the first two pieces of that. So today's topics, you're going to learn what containers are. Notice that doesn't say what Docker is. The next line says what Docker is and why it's so popular. We'll also be learning about Docker lingo, understanding the terminology that is used when we're talking about Docker. I think this is one of the most overlooked pieces of Docker. I've had lots of conversations with people about Docker, and I think to get us on the same page, we need to understand the language, and we're gonna get Docker installed and hello world. We're gonna be doing more than that today. That's just what these slides cover. We have another set of slides. We're gonna be doing a lot more than that. We will get up and running with Docker. We will get hands-on with containers today. So don't worry about that. And we're gonna run through a lot of this kind of fast because we don't need to get into the super nitty-gritty for a lot of these things. All right, so what are containers? Not what is Docker, what are containers? Linux containers, and again, we usually copy and paste from Wikipedia right up front to give you the initial definition. I was gonna remove Linux containers from this. I remember the day I did it, but I wanted to leave that in there because we're gonna talk about the Windows versus Linux, all that other stuff. But Linux containers, in short, contain applications in a way that keep them isolated from the host system that they run on. Now, we've talked about virtualization here. The host system is the main underlying operating system that is that is housed on the physical hardware, okay? So a container keeps it isolated. So that's one of the first words I want you to stick into the back of your head. Hold on, let me see. Oh, Isa Moran. I thought you guys were saying the stream dropped. Okay, that's good. But isolation is one of the first things I want you to just, throw it in the back of your head, write it down. One big piece there. Containers allow for a developer to package up an application with all the parts that it needs, such as libraries and other dependencies, and ship it out all as one package. This is the most important piece that I want you to understand. I want you to understand that containers are designed to help to make applications run. Okay, they're designed for an application to run in, and it packages it up, puts it all in a box, all together in a nice, a nice comfortable package with all of the things that it needs to run, all the pieces. Libraries, binaries, the application code itself. It sticks them all together, gets them all together, and is able to deliver it as one single package. All right, very, very important. That is the, if you ever go into an interview and someone ever asks you, what is Docker? That is what I want you to tell them. Docker is synonymous with the containers at this point. But just say, hey, it allows the developer to package up an application, all of its libraries and binaries and dependencies into one, nice little package to be shipped out all together. That's what I want you to know about containers. All right, so host system. These are some of the terms that we're going to define. Host system, we just talked about that, but the operating system on a computer that works with the underlying hardware. So your Windows, your Linux, your Mac OS, and so your container runtime, your container engine is going to run on a host system. Same way that we talked about hypervisors, type 2 hypervisors that day. Libraries, when we talk about shipping an application with all the things that it needs, such as libraries, binaries, and dependencies, the libraries are just some extra tools and functions that are pulled in to help you support your application. So all libraries are simply some more code. It's some more code that you didn't write, but they're pulled in to give developers extra tools and things to make their application run. And dependencies, these are tools and technologies needed for your application to work. So some of these libraries might be dependencies, or maybe your application is a PHP application, so it needs a certain version of PHP. And so that PHP runtime is a dependency for this application to run. That application depends on this version of PHP to run. It's important that you understand what dependencies are as well, because people will use these terms over and over again. And I'm not gonna lie, as someone who got into containers before I seriously got deeper into software, I knew how to do automation, I knew how to write some scripts, but I wasn't building I wasn't building anything. I wasn't really dealing with software. And people used to say words like dependencies all the time to me. Library dependencies, I'm like, I don't know what that means. Like, you can tell me what Docker is, you can teach me how to use it, but I didn't understand what it was used for when I was first learning how to use containers. So that's why I thought it was important to call out some of these things here. What's up, Torito TV? Welcome to the channel. Sandman, welcome. Veras, welcome to the channel as well. Good to have you. Blunders more, I don't think I got you. Welcome to the channel as well. Thank you so much for the follow. Glad you're here. And before the we'll ship your machine meme, you did. How are the libraries and utilities needed in an application different from an OS and a VM? Good question. They are not. They are not different, D. Preston. Perfect question. Those libraries and binaries to make that application run are not any different than when it is run on a host operating system in a VM or a guest operating system in a VM. They're not different. This just allows you to package it up in a simple way. Now I'm going to tell you what the difference is. I think it's on the next slide between these things to break it down a little bit more, but it's not different. All right, so here we go. Here is the difference between a virtual machine and a container. And I don't find, I say this every single time we pull this up, I don't find this infographic to be helpful when you don't yet know what containers are. I know that's kind of weird, and it's weird that I'm showing it to you now, but it is how things run. I think that this infographic only makes sense once you understand how things work and the underlying way that these things are running. I looked at this again a billion times before I fully understand what was happening, but it can be helpful in bridging the gap a little bit later. So I want you to see it right now. Let's talk through it. And hopefully before the day is over, this will make so much more sense to you. On the left, what we have is a visual structure of the way that an application would run on a virtual machine, okay, on a virtualized operating system. So starting from the very bottom, and we should draw this out manually because I think if you do it step by step, it helps. But let's look at this first. On the bottom, we have actually, we don't even need to draw that manually. Let's draw on it a little bit. Okay, so you have the underlying infrastructure. So this is the computer right here. This is that server. This is the hardware, the RAM and the CPU and the power, all that other stuff. That's where that is, okay? That's the infrastructure. The hypervisor, we talked about hypervisors. It can be either type 1 or type 2. So in this case, this is in this example, this is more like a type 1 hypervisor. It's showing a type 1. So this is something like VMware ESXi, which is basically the operating system of the computer. This operating system allows you to virtualize other operating systems, okay? So we got the hypervisor here. Now, once you have that installed, once you can virtualize operating systems, now you have to install operating systems. You now have to virtualize entire computer systems, okay? And so that's where we have this here. This might be Windows. This might be Linux. And we're not gonna put Mac here because you're likely not gonna be doing that, but we might put Unix over here. It might be all Linux, might be all Windows, but whatever. These are complete virtualized systems, complete with sectioned off RAM, disk space, allocation of CPU, things like that. So it is virtualizing an entire system. So you can already start to think that's pretty heavy, and you're sectioning off from this bottom thing. These are entire operating systems. All of the binaries and libraries, well, whoa, it doesn't like whatever I just did doesn't like it. Let's go back over here. Okay, all the binaries and libraries that are needed for the operating system to run and the application. So inside of Unix, we talked about kernels before. So inside of each of these, we have engines that help these things run. So kernel, and kernel. Kernel's big. Kernel's, again, the engine that makes all these things run. The hypervisor has a kernel as well. All right, the hypervisor has an engine that makes all of these things run, and then you install all the applications that you need on top. Okay, so a lot of different things happen here to make your applications run, to make things work. Okay, and this is a paradigm which is functional and a paradigm which may work for you. What we're talking about tonight is not to say that containers are better than VMs. People will argue this all day. They solve different problems, but the way that containers work and the reason why people like them is because down here, things are a little bit different. Okay, notice how we don't have this big chunk of host or of guest operating systems. There's no guest operating system. There's a singular operating system, which kind of takes the place of the hypervisor over here. So this might be Windows, Linux, or Mac. Usually it is Linux. Then you install the container engine. There are many different container engines. We're going to talk about this, but imagine this is Docker right here. And once we have this, we now can simply run stacks of applications with their binaries and libraries right here. So you pull out that entire middle space with all those operating systems. The reason why this is problematic, the reason why this is helpful is now there is a singular engine. Okay, so imagine if you have one big engine, you got one big engine, and to break it up into virtual machines over here, we're gonna take that one big engine, and that one big engine is now gonna feed 3 smaller engines. So all the big engine power is gonna go into 3 smaller engines, and then we're gonna have to do some other things on top of that. So this one engine is still running everything. It's still powering every single thing that's here, okay? But now not only does it have these applications, these libraries and these binaries and this operating system to power, it also has these other engines to power. Over on the right, we have one engine. And what Docker allows us to do, all right, let me open up a whiteboard here. What Docker allows us to do, this kernel, this is what allows the software, a kernel. So this is one big system, okay? This is a computer system right here. The kernel allows for the software, a little software bubble up here. It allows that to talk to the hardware, okay? And I'll put hardware down here. And again, it's the engine. And it can be kind of heavy. It actually can be pretty large. We already have one of these, so we don't need to do anything special. Because we already have one of these, containers utilize this single kernel and allow you to package up little applications, okay? All these are little applications, and they allow it to talk directly to the kernel, to the engine. And so they all utilize the exact same kernel, which is already running everything anyway, and allow us to work a little bit more efficiently. Because of this paradigm, these container engines and these container runtimes are generally a lot more efficient. All right, they're a lot smaller and they're a lot more efficient, okay? There is no kernel inside of these things. They're not little virtual machines, okay? I wanna be very clear about that. They're not little virtual machines. They do not have their own kernel. They do not have an entire underlying operating system. You can skip the operating system because there's already a running operating system. If there's already one running operating system, we don't need to create a new one. We just pass through, basically we pass through that communication and run our libraries right on top of the main kernel. All right, this can be pretty confusing in the beginning, but I really want you to understand what it is and how it does. And yes, they are little sectioned off, isolated sandboxes. They really are. For this, I'm sure a lot of questions were asked. I'm gonna go up and get those in a second. So that is a container versus a virtual machine. The biggest difference, if you wanna simplify it all the way, the biggest difference is that you don't have to install any guest operating systems here in containers as opposed to virtual machines, because the container runtime can interact directly with the system's kernel, okay? And the second part is simply that containers is not the same thing as Docker. Docker is a container runtime engine, and containers does not equal Docker, okay? There are many more container technologies, container runtimes that aren't even on here. And so I just want you to, when people talk about containers, just know they may not be talking about Docker. Sometimes a lot of people get that confused. They may not be talking about Docker. Let me catch some of these questions if there are any. Also, what's up, Raj? Welcome to the channel. Six Figure Dev, thank you so much for the raid, everybody from Six Figure Dev's channel. Come on in. First off, let me get you a shout out. Let's see if we can type this. Second off, actually. I changed the keycaps on my keyboard and I'm instantly made me a better typist because of their size, something I'm a little more used to. It's made me so much better. I'm not good yet, but way better than I was last week. So, that's very, very exciting. But Six Figure Dev, thanks so much for coming through. Thank you so much for the raid. Hope you all had an amazing stream. What were you doing today? Let's see. Can I run Ubuntu containers on my Mac OS? Yes. Or can I only run Mac OS based containers? Good question, Fig Leaf. No. And in fact, there are no Mac OS based containers as far as I'm aware. There are only Linux based containers and Windows based containers. But yes, you can run a Linux container. You can run Linux containers directly on your Mac. I don't want to say an Ubuntu container because we just kind of talked about operating systems. And again, this is something I do want to be clear about. We're going to get into tonight. We're going to deploy an Ubuntu container, but it is not It is not an Ubuntu operating system. All we learned about Linux distributions. All Linux distributions is simply a collection of software over top of a kernel. That's all they are. It's a collection of software put together that interacts with the kernel. The Linux kernel is the same kind of across the board, and so I want you to keep that in mind. That although this container is an Ubuntu container, it is simply tools that you're used to that run in Ubuntu, rather than it being an Ubuntu operating system. That can be pretty confusing when you're first trying to understand what's happening there. Let's see. What most people think of as an OS is a lot of stuff. Yeah, yep. So what's better? What has better performance, a Docker container or VM on a Type 1 hypervisor? I would think a VM because it's closer to the hardware. So a VM is not closer to the hardware. A VM, a VM wouldn't be close. It would be the same level away from the hardware. My performance is acceptable. And so performance is an interesting thing. Likely the container performance is going to be better. Because let's imagine this. Let's say you had a process. You had one application you wanted to run, and that application was going to have full control over the system. It was going to be possible for you to use 100% utilization of a system based upon with that one application. If you were running that application on a Type 1 hypervisor, so VMware ESXi, so VMware is running directly on the bare metal machine, you've got to install an operating system. So now I have to install Linux on here. So I have ESXi installed. So I have one essential operating system on here. Then I have an operating system installed on top of ESXi. So now I have Linux installed, a Linux kernel and everything on top of ESXi. ESXi is already taking up system resources. Now, so is the Linux machine that you put on there. Now you can install all the libraries and binaries and things that you need and run that application. Great, it'll work fine. You can give it access to the whole system, but the not only are the hypervisor taking up resources, so is the guest operating system. A container, on the other hand, the only thing that will take up space is the host operating system. So you have a bare metal system, you install a host operating system, that's the only thing taking up the power. So, you got a host operating system, which is the same as that guest operating system, but you don't have an underlying hypervisor. You do have that container engine, but that is very, very light. And so you still have access to the whole computer, and theoretically it would give you a little bit more performance. A long-winded answer, but in a one-to-one scenario like that, containers are going to generally give you better performance. Let's see. So what's the secret sauce in Docker that allows me to run an Ubuntu container on a CentOS host? No secret sauce at all. No secret sauce at all. You simply specify that's the container you want. Remember, CentOS is Linux. An Ubuntu container simply will just have some cool things in there that you're used to in an Ubuntu operating system, but it is just some Linux software and packages. But we are gonna dive directly into that for sure. Wraps the kernel APIs. So container has to run less crap than a VM emulating the entire OS. Correct. 100%. That's the statement right there. That's it. You said it. Container just simply has to run less things to be able to emulate the entire OS. Why does an application need a dedicated OS to run? Good question. Erica, the reason it needs that, or Erica, either one, let me know which one, so that I get it right next time. The reason why it needs an operating system is because it needs that engine, it needs that kernel. It needs to know how to speak to the hardware. It needs to know how to send instructions through the CPU and store things to the RAM. That's the reason why it needs an underlying operating system. It has to have something to talk to be able to utilize the hardware. Could there be a case where my container image has an application that only Linux has? How would that image run on a Docker that is running on top of a Windows kernel? Good question. So Windows, we're about to dive into Linux versus Windows, all that other stuff. But the Windows version of Docker simply ships with a Linux kernel, a little emulated Linux kernel. That's all. It utilizes an actual Linux kernel. It does not speak to the Windows kernel. And so you can deploy Windows containers, but they talk to the Windows kernel instead. Don't firmware and old hardware work without any kind of OS? Well, so yes, yes, it is possible, but modern applications are going to need that, especially because these are Linux containers, so they need an operating system because of that anyway. Do you lose the benefit of containers when running on Windows since you are running on a virtual Linux environment? No. Depends. It depends. If you're using, I think that you do if you are running Windows as the operating system that is going to serve your application. Yes. I think so. Yes. It is people who are running, if you're running if you're running Docker on Windows, you're generally using it for development purposes rather than operational purposes. Instead of not equal, could we say includes? We could say that. We could say that. A lot of people think, the problem is a lot of people think Docker equals containers. But yeah, we could change that to includes. That's fair. Docker is a container suite of applications that's compliant with a shared API. Yeah, yep, that. What's up, Amame? Lurking and learning, absolutely. Yeah, so there are other container runtimes. Rocket, LXC, these have been around for a long time. LXC, Linux containers, have been around for a very long time. Docker is nowhere near the first at all, but it has become the most popular for a number of reasons. I think the first of which is, I think, timing. I think the timing of Docker and when Docker was released was super beneficial for it. I think one of the other things is its interface. The way that you interact with Docker containers, I think it feels good, and I think the developers took to this. Yeah, I think that's one of the biggest reasons why Docker took off when it did. We're gonna learn a little bit about that as well. But again, there are other container engines, like Kubernetes now is not even going to be utilizing Docker anymore. It used to have Docker as a engine runtime, a container runtime that you could use. It is no longer even going to support that. Containerd is what it's going to support now. So there's a bunch of things in there. All right, so let's talk about Docker really quick. Specifically, it debuted in 2013. Version 1.0 was released in 2014. It is written in Go. We all love Go over here. I love applications that are written in Go. As most DevOps SRE tooling is written in Go. Well, not most, but all the popular ones written in Go. Runs on Linux, Windows, and Mac OS. And the mascot's a whale. That's helpful for you to know for sure. So why Docker? Why would we want to use Docker? For a consistent development and deployment experience. This is very, very important. Okay, a consistent development and deployment experience. How can you get a consistent development and deployment experience? Well, because everything that the application needs to run is packaged up together. So now it's no longer just the application code that's getting packaged and shipped out. It is everything it needs to run. So it makes it a consistent way to do those things. And it fixes the works on my machine problem, simply because if we're packaging up everything, we no longer need to worry about the, it not working in another place. Now, a little caveat here. So let's read that line. Fixes the works on my machine problem. What's the works on my machine problem? It is exactly what this meme on the right, everyone's seen it. It's a great meme, but it works on my machine, then we'll ship your machine. And that's how Docker was born. And that kind of is the logic. That's kind of what is happening here. We talked about the adversarial environment that's created between development and operations. Because development would develop the thing, they ship the code over to ops will try to deploy it, doesn't work anymore. Ops will say, hey, this is not working. And developers will say, hey, well, I don't know what's going on because it works on my machine. That's usually because there's an inconsistency between the machines that you use to develop on and the systems that these applications are going to run on in the future. So to solve that problem, why not ship your whole machine? So Docker will work. Docker should. Let me just, in 99% of the cases, 99.9% of the cases, Docker will work on any other machine that has an equal version or newer of Docker deployed. Let me make make it very clear, equal version of Docker or newer, because different Docker versions have different features and compatibilities and things like that. So be very careful with that. But yeah, as long as the machine that you're sending this to can run Docker of the same version or newer, your application, you shouldn't have to worry at all about it not working. So that's super helpful. That's a very beneficial thing for you to have. What's up, Gam USA, Game USA, USSA? Try that. What's up, PhD Die Fantasy? Good to have you as well. V's, welcome. Nick Jaws, good to see you. Welcome to the channel. I've been that 0.1 chance. I agree. That's why I didn't say 100%, because I've also been that person. We're doing a trial project for my current employer. The Docker file wouldn't run on the systems I was building. It was a quoting problem. Somehow still ran on theirs. Yeah. I've definitely seen issues on the same version of Docker. So, it's not 100%, but it is very close to 100% for sure. Can't you use make files to require Docker? You can. Yeah, you can. You can, but yes, you lose the benefit of isolation. Okay, so another reason is Docker allows for rapid development. You're going to learn that a little bit more when we learn about writing Docker files. Docker is great because of scalability, because of how small Docker containers are in comparison to other things. It's very quick. It makes it super easy for you to scale up to meet demand because you can make many more of them. And it makes them pretty portable because it'll work on any system that's running Docker. All you got to do is get Docker installed on the system. That's the only thing that you have to install on the system, nothing else. Okay. When you bootstrap your servers, if you bootstrap your servers, all you got to do is get Docker installed. You don't have to do nothing else. And you can deploy your applications to those systems. That makes it pretty helpful. Lingo. Let's get into the lingo real quick. I want to make sure we have time to build some stuff. A Docker image. This is the part that I want you to focus on. I want you to really understand this terminology. It's going to be helpful for you in the future. So what is a Docker image? It's a read-only template that contains a set of instructions for creating a Docker container that can run on the Docker platform. A lot of words there. The line that matters the most is a Docker image is a way to provide a convenient way to package up your application. So an image is the package, okay? It's the package that's created for your application. And so I do want you to be thinking like a DVD right now, okay? I put this little GIF there because I want you to be thinking of a CD or a DVD that gets created. What the Docker image really is just simply a template to tell this application how to be put together. How to be put together, okay? And how it runs, all right? And so that the image is the package, okay? A Docker file is simply a text document with commands necessary to create a Docker image. So the way that you can create this image through code. All right, you can codify the creation of this image, and this is a very powerful thing in containers. You might be saying right now, that's kind of weird. Like, why would I want to do that? Yes, you want to do this. You want to codify the creation of an image. You want to codify the creation of your application. All the things that it needs to run, you need to get down onto paper, basically, because if you have it codified, you can always create a new image. So using this Docker file, so you use a Docker file, that's the thing that you write, that's the code that you do to create an image. All right, you do that, you build it into an image. You can also create an image without writing any code. The reason why you shouldn't do this, or why it doesn't make sense in most scenarios to do this, is because then you have no idea what's in the image. You have no idea how to recreate the image. But there might be times when you need to utilize this feature, but you can create images without writing them down via code. We'll talk about that as well, but this is how you generally are going to be building these things. Docker mostly install this 500 different distributions. Yeah, it really does. Do you codify with Terraform? Yeah. We talked about Terraform 2 weeks ago. Terraform solves a different problem though. Make an image, doesn't matter if it's Python, JS, Docker needs to run an image, language you wrote, does not matter. Correct. Are we gonna use Docker Compose? We might write some Docker Compose on Wednesday. Tonight, we're not gonna write any Docker Compose at all. but we might touch on Docker Compose. We'll talk about it. Yeah, we'll talk about it. We'll see. All right, so let's keep going. So right now, the 2 terms that you need to know that you might want to write down to know in the future is a Docker file is the text document that you write to be able to create an image. And that image that you create is, a read-only kind of structure or template that sets up, the packaging. It sets up the way that the application is intended to run. So a container, what is a container then? We've been talking about containers. A container is a single running or stopped instance of a Docker image. This is very, very important, all right? From one image, okay? You can play a song off of a CD a million times. Off of one CD, you can play a song a million times. You could, if it's a movie, you can watch it a million times. That is the same thing here. You use that image, and from that one image, from that one template, you can deploy any number of containers, okay? So it is one run, it's running or stopped. It's a created runtime from that image, okay? So it is the active running of that application, running or stopped. It's the active creation and isolation of that template. All right, that part is very important. So from an image, you can deploy applications. So right now, you can think about a container as you can think of it as a running version of your application, but it can be running or stopped. All right. Is this one anxiety inducing, or is the other one? Oh yes, definitely this one. Yeah, I agree. It is pretty, but it's overflowing. Okay. It's still a container. But it is what it is. Let's see. Let's go to the next one so you all don't have to look at that too long. Registry. We'll come back to registry. Build is simply the initiating the commands in a Docker file to create an image. So you have a Docker file and you build it. You build it to create an image. That's the flow. You write a Docker file, you build it, which creates a Docker image. And once you have that image, you can now run your containers based off that image. All right. That's the flow right there. So whenever you hear build in terms of Docker, you're talking about building, creating an image from a Docker file. And let's talk about registry and tag really quick. So Docker Registry is simply a storage and content delivery system that has named Docker images. So what does that mean? So what is a Docker image? Well, it is that packaged up template. It's the package, okay? A Docker image is the package. We can store these packages in a registry. All right, if we don't want to have to keep building these things, we don't have to keep building these things. We can store these already created images, these burned DVDs. We can save them in a registry. Think like GitHub. It's called the Docker Hub is the main one, but you can store the images there so that you can retrieve them at different times or anytime you want to retrieve them. And a tag, it allows you to add a unique identifier to an image. The name of an image is the name of an image is a tag. And so, yeah, that's what you want to do. Could you use Docker to run an iOS app in Windows and get a GUI? No. No, for a number of reasons, SimCity. One, because of the underlying operating system, it wouldn't be supported for one. And you can use Docker to get GUI applications running. It is a hassle. You'd have to, it can be a big hassle to do so, but yeah, mostly because of the operating system. AWS has ECR. Yep. So there's a container registry inside of Amazon. I'm pretty sure everybody has one. You can also set up your own container registry. A container registry, to set one up, it's just a Docker container. So if you were to go on Docker's website to find out how to set up your own registry, you just run a container and then you point your Docker stuff to it. But yeah. All right, so those are just a couple of the terms. There are more terms coming later, but let's get into the installation and let's start playing with this stuff right now. Can you run a VM in a container and then emulate iOS and Docker? No. Well, can you? I don't think you can. So I don't think you can run a VM in a container. The reason why I don't think you can run a VM in a container is because I don't think, because of the isolation, I don't think that you can provide pass-through. Yeah, I don't think you can provide pass-through to a lot of the things that are needed for a VM to run. Maybe there's a way to run it. I don't think that there's a way to do that. But if there is, point me in the right direction. Definitely point me in the right direction. But I don't think so. What's up, Unique? How you doing? Yeah, I don't. Ugh. So one of the biggest reasons why I don't think you could run a VM. So I think I definitely want to know more about this, because one, you'd first have to be able to install a type 2 hypervisor inside of the container. So that's the first piece. I think that's where you would run into some serious issues in installing a type 2 hypervisor in a container. Again, I think that also has to do with access. Your container would need access to, I think, more things than it possibly can have access to. But maybe you can do it. I'd like to see that. I definitely like to see that. Oh yeah, we can go over back over parts 1 through 14. So, one, what is DevOps? Only a joke. But if you want to check them out, they are on YouTube. If you do want to check out the other parts. All right. So let's get Docker installed and let's start playing with it. It'll make more sense once we're playing with it, and it might be, fun and easy to do. So you have a bunch of different options to do this. Okay, you have a lot of different options to install this. 2021 is a great year for tech because this used to be a problematic part of this course. You would get here and you would ostracize immediately all of your Windows users. Right here. We're gonna go to docker.com. Maybe it's docker.com. That feels like the right website, but Docker works on every platform. There's a way to install it on every platform. Whomping Willow, thank you so much for the Twitch Prime sub. That's love right there. Thank you so much. I do appreciate it. But Docker runs on Windows, Linux, and Mac. It is designed around Linux containers. It does also work on Windows containers, for Windows containers. It cannot do both at the same time, okay? So if you were to install Docker for Windows, if you worked in a Windows-based environment, if you were doing a lot of .NET stuff, you're doing all the .NET Core, all that stuff, and you were using Windows for this, you could use Windows containers. That is okay for you to do. And it does work, but you can't also utilize that with Linux containers. Docker has a few different ways for installation. Even on a Mac, I think that Docker installs its own little virtual machine. I think. I could be wrong, or it might interact with the Unix kernel, but I thought it installed its own little thing. There is a Docker for desktop for both Windows and for Mac, okay? There is a Docker for desktop. Really easy to install. Let me just Google install Docker. Y'all see that typing? The typing's better already. It's better already. You just change your keycaps and it's better. A couple different ways. So easy to install on the Mac. On the Mac, you click on it, you click the buttons, you download it from Docker Hub. You do have to sign up for Docker Hub now, which is kind of trash. Not gonna lie, it's a little bit trash. But you can do that. You can, or I guess you can do it via Brew. You can get it installed. No big deal. Windows, you can do it this way. Click through and get some stuff installed. Now on Windows, it's gonna make you enable some things, I think, or is that not the case anymore? It used to make you enable a Hyper-V, I believe, which would cause issues if you also ran VMs on your computer. This is one of the problems that Windows users will have. If you use virtual machines and you had a type 2 hypervisor, you used to have to enable Hyper-V for this to work. But I think now you have to enable Hyper-V anyway to do WSL2. If you run VirtualBox specifically. Okay, yeah, you can run both now, which is super helpful. And so I think you still have to enable Hyper-V regardless to get it installed. But it is pretty easy to install. It's nice, it has a good interface. You can go through and do that if you'd like. It's helpful. Linux, on the other hand, there is no Docker for desktop. It is the container engine is a package that you can either install from source or utilizing your package manager that you can get installed. If you're using Docker on if you're using WSL2, all right, you cannot, at least as far as I'm concerned, someone let me know if I'm wrong, you cannot simply install Docker. It will not give you, it will not work. It will not give you all the functionality that you need. What you have to do is you have to install Docker for Windows. And then now Docker Desktop for Windows has a little button in there for integration between WSL2 and Windows. It works surprisingly well. It works way better than I expected it to work because it didn't work on WSL1. That is an option for you. It's simply a checkbox. You just check the box when you install it on Windows. It says, hey, go ahead and integrate with my WSL2, and it works just fine. As far as I know, though, it does not just work in WSL2 alone. Like if you were to install it there, I think you would have some problems. Will this work with AMD processor? Yes, it will work with an AMD processor as long as you have virtualization enabled in your BIOS. But for all this sounds super complicated, you know, there's a lot going on with this. This is why I'm going to use Linode. I'm going to simply use a Linode VPS. Yep, I use AMD. I was almost all AMD over here, but I need CUDA from NVIDIA. I also need their NVIDIA broadcast features and some other stuff. But I'm going to use Linode. Linode has a one-click to install, but I'm not going to use that. I'm just going to get a VPS. If you want to follow along with your own server, again, for free, if you click below the video, you can get $100 worth of credits from there. I think it's a little bit, if you're worried about the setup that we've been talking about, we just talked about like 9 different caveats. You don't want to have to worry about that. I'm going to hop into Linode and work off of that. Yeah, Raspberry Pis. If you have Raspberry Pis, that's a great place to run Docker containers. 100%. Great place to do it. I almost picked up a Pi Zero. I want to see what I can do with the Pi Zero. It seems like it doesn't have enough stuff, but yeah, whatever. Break, good to see you. Neutron boy, Jim, welcome to the channel. Thanks so much for the follows. Not much, I bet, but it's so cheap. I feel like I have to see what I can do. All right, so I'm gonna hop into Linode right now. I probably should tear down a bunch of stuff that I have in there, to be 100% honest, because I might be out of credits, but it's okay. You can do a bit less than a minimum VPS for most providers. That's actually very helpful to know. They have guys that set up Kubernetes on Raspberry Pis. Yeah. I mean, there's K3s. You can do full installations. You can do a lot of stuff. So I'm going to create a Linode really quick. I'm going to use, it doesn't really matter which you use. Again, we stick with Ubuntu here for the most part. I'm going to do Ubuntu 20.04. I'm going to put it in my region, this is closest to me. I'm not in New Jersey. For this time, you guys gave me a lot of flack for choosing the 2 GB Linode. So I'm going to go back to the Nanode, all right? So the $5 a month one is perfectly acceptable for everything that we're going to do for all of this. Won't give you any issues. Call it whatever you want. I'm going to call this Pipelines Docker. Come on, did y'all see that accuracy? I only had to backspace one time, killing the game. All I had to do was change the keycaps. Super helpful. All right, password. I am gonna look down for this password. I'm not gonna use the one that's there because you all can see it. And cool, we will go with that. I'm gonna get set up here and I'm gonna take you through a real Docker installation rather than doing the one click. You also, if you don't wanna do this part isn't super crazy important, but I do want you, because we're diving into it, I want you to see what the installation looks like. You can just do, if you create Linode and you go to Marketplace right here, you can simply click Docker on here somewhere. It's somewhere on this list, Docker. You can click that and click create, and it will provision you a server with Docker already installed on there for you. You don't have to worry about any of the extra fancy things. All right, so now that is getting spun up for us, it's probably already up, Pipelines Docker. Let's go ahead and get logged in to this server. And let's hop in. Ugh, you know what's gonna suck? We're not gonna have our sweet prompt. We're gonna have old ugly prompts. I'm not a huge fan of old ugly prompts, but it's okay. We'll just do it anyway. All right, so first thing I'm gonna do really quick is I'm gonna do an update just so we can get going. Keep an eye on, try to snipe for Ansible ebook, for DevOps ebook, sales giveaway. Oh, dope. I do want to dive in some more Ansible stuff for sure. All right, so we have this updated. Now we're gonna go through the installation process for this. Oh no. Oh, that's a song change. Okay, we're gonna go through the installation process. It's pretty simple. There is a packaged up version for most systems. The problem is I've on Ubuntu, at least, I've experienced nothing but problems trying to utilize the package managed version of Docker. There's also like 3 different packages. It's like docker-io or .io. There's like Docker Engine. There's a bunch of stuff that's problematic here. I'm gonna install it the way that they tell you to install it on here. So I'm gonna click on the install. I'll share this with you in a second. When I get there, we'll install this on Ubuntu, and we're gonna run through this very fast. It's all copy and paste, nothing special, okay? Simply copy and paste. Make this a little bit larger so that you can see it as well. And we're just gonna go down and do this. So you might have some other Docker stuff. So remember I told you there are a bunch of different Docker packages. Docker is one, Docker-Engine is one, Docker-io is one, Containerd is something that you can use. There's also Podman, there's a bunch of other things that you can use in place of this, whatever. You can simply go through and delete these. Are these recorded? Yes, they are. Hit ! YouTube, you can find them there. They're here on Twitch for 60 days. But yep, they are installed. I mean, they are recorded. So I'm gonna click this. I don't have anything installed, but you might on your own system, if you are doing Ubuntu, if you have an Ubuntu system, you might have something installed. It's good to remove everything first to make sure you're not gonna have any type of, clashing packages and things like that. And then we're just gonna hop down to getting set up. They're gonna have you set up a new repository so that you can pull the most up-to-date things. We just did an apt update, so I'm not gonna run that, but we're gonna run this command right here, which is going to install a couple of packages and things that we're gonna need to make this thing get up and running. I'll simply paste it in there and we will run that. What's up? Not excuses. Welcome to the channel. Dark Cult. Good to have you as well. Fractal, welcome. It's good to have you all here. I hope you're ready to learn a little bit about some Docker. And we'll do yes, we'll get that installed. That's gonna get the packages set up for us. Pretty simple stuff there. The next thing it's gonna tell us to do is simply to add Docker's official GPG key. This is just going to allow us to do some verification of the packages, make sure that what we are installing is in fact the right thing. So you don't really have to sweat it. It's a pretty simple process. Like I said, copy and paste the whole way. What's up, Vacant? How you doing today? Thank you so much for the follow. So we do that. It lets us know, hey, we're okay. We got the right thing. You can run this command too. It's gonna print out a fingerprint. I'm not gonna print that out. I'm not gonna run that. Run it if you want. It just verifies that everything is a match. I trust this. Pulling it off of Docker's website, but it's all good. Here's what I'm gonna do here. I'm gonna simply add the repository they want us to add. You can add a nightly build or something if you want. You can change stable to, I think nightly is the other thing that you can do. You can change it to a non-stable build, a development build, things like that. But we're simply gonna copy this command here and we're gonna add this repository. Pretty simple process. After you add a repository, you must do an update. So I'm gonna run apt update again. It tells you right here. So now we've kind of set up the computer. I'm gonna talk you through what we just did. I know a lot of you are new to this. We basically cleaned the computer with the first command, making sure that we didn't have any older Docker stuff on here. And then we set up our computer to be able to know where to pull the Docker packages from. So, we set up a key and a space for it. And then we verified that the packages that we were gonna pull were right. We verified a fingerprint. And then we added a repository. So now our package manager knows where to pull stuff from. All right, so it now knows. We install some extra tools that Docker's gonna need to run. But this part here, all of this part right here is simply setting up a repository. So our package manager on our machine, when we do an apt install Nginx, it's pulling that from a server somewhere. It's pulling that from a server, and it's set up to know where to pull that data from. Right now, we're setting up our system so that it knows where to pull the Docker packages from. So when we're adding a repository, we're adding a location that our computer will now know, that our apt tool will know where to pull Docker information from. All right, so that's what that did. When we run the update, it doesn't know where to pull it from until we do the sudo apt update here. How come our computer knows Nginx but not Docker? Great question. Because by default, the computer will come with a bunch of repositories already set up. And so if Docker packages their things up and publishes their package to the mirror or to the repository that is already created for apt to know about, then it will be able to find it. But people can also add their own custom repositories to apt as well. So yeah, it's simply a way of packaging these things up. There are some Docker packages that are there, but the official Docker package, I guess, doesn't get packaged up and put there. Invalid. Oh yeah, I spelled that wrong. It is not update, it is update. So now that we've updated it, our computer knows exactly where to go to get this stuff. So now we're just going to install Docker CE CLI in containerd.io. That's kind of new to me, the containerd part, but makes sense. And there we go. Also politics stuff. Yeah, there's a process for releasing into official Ubuntu repositories. Yep, and a lot of companies just opt to do it on their own, to run their own repository to get around that. That's 100% correct. It's kind of, I mean, honestly, it's kind of like if you were a movie maker and, you know, you wanted, you know, people have Netflix and you wanted your stuff to be deployed on Netflix, but it can be a little bit of a hassle to, maybe there's a lot of hoops that you got to jump through to kind of get your stuff there. I don't know. It's actually more akin to all the wildness going on right now with the Epic Game Store and Fortnite and Apple. And, you know, to publish their games on iPhones, they need to go through the the Apple Store, the App Store. But because of that, they got to give, you know, 30% of the proceeds or whatever back to Apple. So they're trying to sidestep that. They're trying to fight them so that they can deploy their own app store onto iPhones. That's what their goal is right now, is deploy their secondary app store so that you can grab their stuff from their own app store from the side rather than going directly to the app store. It's kind of the same thing here. Now the money's not the same thing. It's not the same situation, but there are hoops that you have to jump through to kind of get everything verified and set up and all that. So now we have Docker installed and set up on our computer. There is some post installation steps that you might have to do. They'll tell you some other things in here if you want to do some specific Docker stuff. But I don't want to do any of this. I'm going to keep scrolling down until they tell us the post installation steps. Right now, if I were to try to run Docker, for us, it's going to be fine because we're already root. All right. But on most machines, you are not going to be root by default. And so you would have to do some post installation stuff. For me, this is just up and running. Docker is working. How do we know Docker is working? I just did a Docker PS. This is Docker processes, I guess. And we get some output here, and it's just a bunch of headings, okay? We see container ID, image, command, created, status, ports, names. The Docker engine, the Docker container, it's running now. So if I did a, system, CTL, what's the Docker status? I always get it wrong. I always get the order wrong. And we can see that Docker is in fact running at this time. Cool, up, running, but we haven't done anything with it. Let's hop into our next set of slides. We're gonna breeze through these next set of slides to make sure we can know what's going on here. What's up, son? Welcome to the channel. Good to see you, love the name. Our part two, real quick. Let's talk about how to get up and running with a container. Let's talk about how we can work with images and get up and running with a Docker container. So we talked about the registry a little bit. Hub.docker.com. It's really funny to me now because someone, the last time we talked about this, someone referred to Docker Hub as the hub And then people then proceeded to make a bunch of Pornhub references, which I found to be very funny because I don't know how I didn't see it coming. I never saw it coming. I always see jokes like that. I always see them coming, but I didn't this time. But hub.docker.com is the default repository for all container images. The way that Docker is set up out of the box, it's set up to pull container images from right here. If we were to try to pull a container image, it will come from right here. Let me sign in real quick. And yeah, we can explore container images. We can see a bunch of applications that we can just pull from. These images are public, all right? So all these people have put these things out here. There's a bunch of official images and things. We can pull these and use them. We can use all of these images here, okay? It's a bunch of stuff. If you wanna see if there's something that you wanna use, you can go in here and you can look for it. It gives you a bunch of information, not just about how to get it, but also how to use it. It'll give you some references. It'll also give you some references directly to the code that was used to create this image. All right, so not only can I see like some instructions on how to use this thing, I can also see the code. And let's take a look at some of the code because you've probably never seen it before. This is what a Docker file looks like. It's actually just, they're not difficult to write. It's just a bunch of Linux. I know this looks super confusing right now, but it's just a bunch of Linux commands all strung together with some special Docker things keywords and things that you need to know about. So I think you do not need an account to pull data from it, but you do need an account to look around it. I don't think you used to need an account, but I'm pretty sure they require an account for you to now like look around, which is very, very annoying. It's free. But you don't need to, I'm just telling you where it is. You don't need to do that right now. What if you wanted an image with say Nginx and Golang, but you could only pick one of the images? Ooh, fig leaf. Good. Oh, good question. Hold on. Let me see. What were the topics for this part? Let me see. Do we get to running containers? Okay, I'm gonna give you the answer to this right now, and then I'll talk about it. So your question is actually an interesting one because you can absolutely do that. You can absolutely run whatever processes you want to run inside of a container. If you wanted to use one of the out-of-the-box versions, if you wanted to use, say, the Nginx container, you have a couple different options here. You can write your own custom Docker container that utilizes Nginx, and then you could install, using your Docker file, you could install Go inside of this container. Your Docker file allows you to customize anything that you want. You could also remember how we clicked install the code here? You could literally take this code right here. This is how they're building Nginx, and you could just put in a command in here. You could put in the instructions here to install Go if you wanted, and be able to build an image directly off of that. I think your question is super interesting because we're gonna talk about the ethos of containers and some things to keep in mind. Containers are generally designed to run one process, all right? That is a general statement. They were designed to run a single process. And if you need to run other things, you generally are supposed to run those in a completely separate container and connect them, okay? So pretty interesting. But yeah, you could absolutely run both of those things in the same thing. You just would have to create your own image with the things that you wanted. And most of the time you're gonna be creating your own image anyway. The next Moses, welcome, It's J Fields. Thank you so much for subbing. First off, shout out to It's J Fields as well. Let me give you a shout out here. It's J is a part of one of my stream teams. I don't know which one you're on. I don't know if you're on Only Devs or if you're under Podgrammers. I think you're on Podgrammers, but always doing some fun stuff here on Twitch as well. So definitely give It's J Fields a follow. Appreciate you coming through. Thank you so much for subbing. Podgrammers, go give them a follow. Someone asked me about my stream groups today, and I was like, man, I'm in like 5 of them now. So like I get a little confused. I don't know who's in who's in what. So cool. So you can go through and you can make whatever you want. So let's run through this real fast. Docker Hub, that's where you can pull Docker images down from. We're gonna go through and pull some images. We're gonna have just enough time to do all this. We're gonna have a lot of fun here. Trying to be like, I'm just trying to be like everyone else. Look, I'm trying to be like Ninja out here. I'm not gonna lie to y'all. People say they're just on here to have fun. No, I want Red Bull. I want Red Bull to give me a refrigerator that sits right there. I want that refrigerator sitting right there, and I want it to be full of Red Bull, and I want to grab one and pop it open. But I want it to be full of LaCroix, actually. With LaCroix, come on through. Come on through, and we'll just pull, a little refrigerator, pull it, and I want like that. I want to be like that, okay? So I appreciate that. That means you want to be like Ninja too, because I'm trying to be like Ninja, and you trying to be, what's up? What's the official time in 9? Today's gonna be 9. We're gonna have a 9 and 9:15 night tonight. I think we're gonna get there. Okay, so let's keep going. Running and managing containers. Yeah, we talked about the Docker Hub. You don't need to, again, tonight's not the night to become an expert on all that stuff. Running and managing containers. I don't know why I'm missing the A there. Things that you should know. We were right there. Only one. Containers are designed to run a single process. This does not mean they can only run a single process, but they are designed to run a single process. So, as you're building these things, I want you to keep that in mind. Designed to run a single process. They are not like VMs. We're about to see that. They're not designed for you to take a container and install all of the different pieces for your application. Like, I know that, well, saying it like that contradicts what we said before, but it's not for you. Like, let's say you were doing WordPress. WordPress is not run out of a single container, or shouldn't be run out of a single container. It is actually run out of, I guess it's only running at 2, possibly 3, depending on your setup. It's 2 different containers, one with, so they're all Linux, so it's a LAMP stack. So, but Apache and PHP work together, work in tandem if you aren't using PHP FPM. So those go together because it's still one process. And then MySQL goes into another one. So different stacks are going to generally have different containers that are put together to make it work. Amame, did your first push to the GitHub last night? That's amazing. That's amazing. Or to, I don't know where you pushed it to, but your first Git push, amazing. Where did you push it to? Was it to GitHub or was it somewhere else? Was it to GitLab? Was it to Bitbucket? Was it to your own fancy repository? Could have been any of those things. All right, so this next one is a gigantic piece of containers that you must remember. Ephemeral. Containers are designed to be ephemeral. They are not designed to be long lasting. Once their process completes, the container retreats into the night. Okay? So containers are designed to run a singular process, and when that process ends, the container is done with. That does not mean you can't do anything else with it later, but it will die. Okay? This is good to know. It's very, very important to know. Ephemeral. It's not designed to be long-lived or to run for a long time. Designed to run once this process stops, it is designed, the container stops, okay? Very, very important here. This is also something you want to keep in mind for data, and we're going to get into the data next line. Persistent data, it does not have persistent data by default. Containers are ephemeral, and therefore the data that is stored inside of a container is ephemeral as well. Ephemeral means not for a long time, okay? Here for a good time, not for a long time. Ephemeral means it will not stay around for long. It is designed to be temporary, and it will be deleted, okay? You can try to treat your containers as, as pets. It will cause you issues. Amame, thanks so much for the gifted sub to Girl with Box. Also, what's up with Girl with Box? I didn't see you there. Shout out, first off, to Girl with Box. She does some dope stuff here on Twitch as well, right in the science and tech section if you want to see someone else doing smarter things than I do. I'm just here teaching you what someone once taught me. Girl with Box is building things. This is making things happen. We're just out here. Let's see. Containers are a great way to force yourself to have servers as cattle and not pets, 100%. And the first time I ever used Docker man, I did it all wrong coming from a sysadmin lifestyle. I got one. I spun up a container. I spun up an Ubuntu container and was like, oh, I got it. It's a mini VM. I installed everything in there. And when I tell you I was heartbroken when I lost all my stuff later on, it definitely hurt a lot. It hurt a whole lot. Let's see. Marcus, thank you so much for the tier 1 sub. I appreciate it. Again, congratulations on no longer needing to see ads and having access to some sweet emotes. I love it. I appreciate it. Thank you so much for the support. I don't want to be part of the robot uprising. That's fair. I appreciate that. I will do my best. DevOps equals the devil's line of work. You heard it here first. I mean, you know, if it is, I was unaware, but you know, I'm just doing what I'm doing. What's up, Sympathy? How are you doing? Well, first off, I feel for you. My heart goes out to you. I don't know when you're gonna start streaming again, but welcome. I'll give you a shout out as well. If you again, if anyone's trying to learn, there's a lot of streamers here doing some great stuff. Again, I'm just teaching y'all what I've been taught. Okay, there are people here who have minds for making cool things. You know, we're gonna get there, but not, you know, we're working on it. But good to see you. Glad you came through for sure. Okay, so persistent data, that's what you need to know. You need to know that containers are ephemeral. They're designed to be ephemeral. So, and they're designed to run one process. You can get around all of these things, but you need to understand that they're designed to work in this way. So let's go ahead and let's start to run containers. So we're not gonna go through any of this. This is stuff that you'll learn if you come through to the Contain series. But I'm gonna go through this on the command line for you because this week is not about you becoming a pro at Docker. Contain will run in March. All right, so if you wanna come through, 6-part series on Docker, you'll learn it. Let's get containers running. Let's start diving into these things. Let's get hands on. So a container image. If we don't have a Docker file, remember we said a Docker file is needed to build a container image. But we haven't done that. We'll write a Docker file before we leave here tonight, but let's grab an image that already exists. We talked about the registry and we talked about hub.docker.com. If we go over to hub.docker.com and say we want to use Nginx, because Nginx is just the perfect tool to showcase everything, to be honest with you. And that's why people use it for this. The way that you get it is simply to pull it the same way that you would pull Git code. This is a registry. This is a repository. The same way that you would pull Git code is the same way that you would do this. So you're going to pull down an image to your computer and we're going to see something cool happen here. So I'm going to run docker pull Nginx, but first I'm going to show you that I don't have any container images to run. You cannot run a container without having an image, and I'm going to type in docker images. This is going to list out the images that are available to us to use. I have no images for us to run containers off of, okay? So I'm gonna go get an image so that I can run a container. So I'm gonna run docker pull Nginx. All right, I'm gonna paste that in. Take a look at what's happening here. This is, what you just saw was a little teaser to one of the things that a lot of people love about Docker, and one of the things that you can use to your benefit when you're utilizing Docker. Notice how there's all these hashes, and it says pull complete on all those. I only pulled down one image, but I got a bunch of different things. These are called layers, all right? And layers are very important in Docker, and they can help you do a lot of different things. But each of these containers are built up of these different layers. What's good about this is you have these layers, that means you can cache layers, which can save you some time when doing downloads and things of these. And if you were to change this image that we just pulled, I would only, if I were to pull an update, if an update was made, I'd only need to get data from the layer that has changed and beyond, which is helpful. So you can structure your image in a way that, like, anything that might change in like if your application is the only thing that changes, that might be the last layer or one of the lower layers in your setup, so that, you know, you can always cache the top layer of things. You know, we'll talk about layers in the future, But we do now have, we've downloaded a newer version of Nginx. Now, if I do Docker images again, I now do have an image listed here. The repository, it's Nginx. The tag is latest. Again, tag, we talked about those, the kind of named section of this. It's tagged as latest. It gives us a unique image ID, when it was created, and the total size of it. So this is the template that's going to tell this container how to run. So we got that. We can download however many images we want. If we wanted to go back, let's go back and see what else we have here. I think we saw a Golang one. Let's grab Ubuntu. Let's grab Ubuntu latest. All right, so we'll do Docker pull Ubuntu. All right, and I actually have no idea what version this is. But actually, maybe I don't want Ubuntu. Maybe I don't want the latest. We don't know what latest tag is gonna be, but you can kind of look down here and see that latest is 20.04. Okay, so latest is set to 20.04. Maybe I want 20.10. I want 20.04. I was actually hoping latest would be 20.10, to be honest. But I'm gonna grab, if I wanted 20.04, I could specify the tag 20.04 and it will pull this one rather than one of these other ones. Or maybe I want 18.04. So actually, let me do that. Let me get 20.04. If I want that one in particular, with the colon, this is the name of the image, and then the tag, I can put a colon here, and I can say 20.04, and this will pull a specific container image for me. It'll pull one specific one. All right, and if I do Docker images again, so I can see my images, check that out. I have Ubuntu 20.04 right here. It is only 72 megs. Notice how the, when you're thinking about, you might think that Ubuntu is I just downloaded an operating system. Notice how an Ubuntu 20.04 is smaller than Nginx. It's smaller than Nginx. And that's because Nginx has a bunch of other things in it, and it's based off of some other things as well. Should never use latest in your source controlled images. I agree. I 100% agree. Okay, so now we know how to get some images with the pull command, and we have some that we can work with. How do we run a container? The way that we can run a container is with the Docker run command. So we have some images. Now we can run a container. What I'm gonna do first is I'm gonna do a Docker PS. When I run that Docker PS, this is going to be the way that you can see information about containers on your system. This is how you see running containers. Docker PS shows you running containers only. All right, they can be running or they can be stopped. If I want to see all of them, I can do a -A. That's for all. Still nothing there. Okay, just nothing. Docker images versus Docker image ls, same thing. Oh, actually, I've never run Docker image ls. We can look at the man page in a second. But yeah, looks like it. I've never done, oh, actually Docker image, same thing. Yeah, I guess so. Looks the same to me. I've always just used Docker images. But I guess Docker image ls could get you the same thing as well. Yeah. What's also interesting is as you get farther along in your career, you're going to use Docker itself less and less. So sometimes I'm probably going to forget about some of the things that we're going to do here. You're going to use other things to utilize containers rather than Docker itself. Warning, due to the engines existing in package JSON, file and node, version defined, error found. Oh, it looks like you got a weird thing going on there. Presumably, if you opt to use Nginx image, you are at the mercy of the author when it comes to which OS the image is used. Yeah, if you want to use different OS, you create your own image. Correct. That is 100% correct. So most places you're going to go, you're going to be building your own images. You're going to build your own images because of that reason. You are at the mercy. You don't want to be at the mercy for most of the time. You don't want to be at the mercy of the people. You don't know what they're doing over there. Yeah, you might feel that they can be trustworthy, but you don't want to rely on outside parties to make your stuff work. So you usually build your own. Okay. So we are going to run our very first container, and I can say Docker. run Nginx. All right, so Docker run is the way that you do it. And then the name of the image name. So Docker run, and then the image that you would like to run a container based off of. And so you could do the whole thing, which is Nginx latest, but it'll always choose the latest tag by default. So if I do this, it begins to run and we begin to get some output, right? And we begin to get some logging. And this looks like Docker. This looks like Docker, but it also looks like some Nginx stuff. And with Docker entry point, configuration complete, ready for start. Looks kind of good. But take a look over here. I'm like, you know, it's still consuming my standard output. It's still consuming my terminal. And I'm like, hey, how do I know if this is working? I could go check, but I'll tell you right now, it is not accessible. That's fine. Like, but the reason why it's not accessible is something else we're about to learn. But the Nginx application is running right now. At this point in time, the Nginx container is running. If we were to log back into this instance right now, we could see that it is running. And actually, let's do that. Let's do that because I do want you to see that it's running. You know what? Oh, there we go. My Windows key wasn't working. I'm gonna log back in and I'm gonna do a Docker PS and check that out right there. We do have a running container, okay? It has a unique container ID. The image that's running is Nginx. It tells us the command. The command is essentially the command that the container was started with. Remember, these were designed to run one process. So the container gets executed with one specific command, okay? And so it tells us that this is what it was executed with. It was created about a minute ago. The status is that it's up for about a minute, ports 80, and it gives it a name, Keen Albertini. So Keen Albertini. It'll give it a unique name every single time. It's pretty cool. It's great. But this is running in the foreground, which is kind of annoying. If I hit Control C here to stop it, and I do a Docker PS, this thing is not running anymore, okay? It is no longer up and it is no longer running anymore because it was running in the foreground. Part of learning Docker is going to be learning the caveats around actually executing and running the container that we want to run. So, you know, okay, great. Let's do another thing. Let's, if you want to run, you can run containers in the background. We could use, if you ever want to know what to do, you can do Docker run -- help, should give it to me. And I can get some of the options that I could use. You know, it's a lot of stuff here, a lot of options here. There are a lot of runtime configuration options for Docker. It can be very, very annoying. But let's go ahead and give you some of the more important ones that you want to do. And these are ones that you can kind of count on at all times. The first one is the way that you run a container in the background, the way that you run it not in the foreground. If I wanted that container to just run, actually Nginx is a bad one to show this. Let's do it with Ubuntu real quick. Let's actually do one with Ubuntu. I'm gonna do, actually no, let's do it with Nginx first since we already started with it. Nginx, Docker run -d. This is for detached mode. And so basically this is gonna run it as a process. Some people call this daemon mode, you know, to run it as a daemon, but this is detached mode. And so it'll run it, it'll separate it from your current session and it'll run it in the background. So if I do Docker run -d Nginx, this will now run in the background. What it does return is it returns the container's unique ID, and then it gives me back my terminal, which is helpful. If I want to ensure that it's running, Docker PS will do this for me. And I can see that, you know, this is the same thing as this here, the unique identifier of this. Super helpful, gives it a new name. This container is now running. I want to show you something else. If I do a Docker PS -a, if I do a -a to see all, notice how there are now two containers here. There is the one that's currently running right here. There's also the one that was running before. Remember Keen Albertini? It is here. That container still exists on the system. I did say they were ephemeral, which is true, But there's some cleanup that has to happen if I want to remove that. The containers are still available here on the system if I do a -A, but it is in a stopped state. Okay, it's in an exited state, so it's not currently running. Now, I'm running Nginx on my system. Can I get to Nginx? Can I just go here and see that this thing is running? Let's see. This is the IP address of the system. No, you can't see it. It's not exposed. The reason why this is another big thing. Remember one of the first words I told you to memorize tonight was that these are isolated. Docker containers are isolated from the host machine. All right. So this process is running. It's running on the system. It is active right now, but it is isolated from the host machine. All right, which means that I can't access this stuff right now. So everything that you're gonna have to do with Docker is to realize that they run in an isolated fashion, and you're gonna have to learn how to make that isolated application interact with the rest of the machine. For Nginx in particular, one of the ways that we can do this is through port mapping. I'll show you that in a second. I wanna show you something different real quick. One, to stop a Docker container, we can do Docker stop, and then we can, we can use the container ID right here. We can also use the name. These are the two unique identifiers, so the name will always be unique. It has to be unique. If you try to run a container with the same name, it will fail. So you can use either the name or the container ID to stop it. I'll show you another little trick. A lot of times people go in here and they will copy and paste. That's great. You also only have to put enough information to make it a unique identifier. So if I type in 3 right here, because it starts with 3 and it's the only container that's running, it will know which one to stop, okay? So now if I do a Docker PS, I have no running containers. But if I do a Docker PS -A, I can see that I have 2 that are exited. You can restart a container. So I could start a container back up that is exited. We're not gonna do that right now. I wanna show you something though with the Ubuntu container. If I do a Docker run, Ubuntu, let's do a Docker run. Yeah, Docker run Ubuntu, okay? Oh, okay. So what just happened here is, I wasn't really thinking, is when you do this, when you type in the name of an image without specifying the tag, it will always do latest. A Docker run command will pull an image if it does not exist. So I could never have done a pull. If I wanted to run Nginx, I could have run Docker run Nginx, and it would have checked locally, said, hey, I don't see a container for this. I don't see an image for this. I'm going to pull this image, and it will pull it first, and then it will run it. Here, it pulled latest because I wasn't using latest. I was using 20.04. So it pulled latest for us. Now we have 2 different Ubuntu images, and it actually ran it, okay? So if I do Docker PS, notice that nothing's running right now, even though it kicked us back out to the console. Notice how it kicked us out to the console, whereas Nginx did not. It ran the process and it kept us in here. If I do a Docker PS -A, this Ubuntu image is here. It ran about a minute ago and it exited. If there's an error running a container, you will get an error. If it's here, it ran successfully. The Ubuntu image ran successfully, and the command that it ran was /bin/bash. Because remember what I told you. Remember I told you that these containers are designed to run their process, and then they are designed, like once they run the process, they exit, they retreat into the night. They're done. Its job has been served, great. If you should run, you need to be thinking about this when you are building your containers. The command that, if you need a long running container, if you need to have something that is long standing, the command that you issue for the container to start must be one that will continuously run and listen for things to happen. All right, it doesn't exit. It does not exit. The command cannot exit. When it executes this bin bash, all bin bash does is execute the bash shell. But once it successfully does that, it does deliver back an exit code. And therefore, because the exit code is delivered, the entire process is done, and the container itself is now done. It's completed its job. Let's see, container, run life cycle graph. So there's a graph here, not life cycle, lifespan. Where, yeah, here we go. Something like this. So this little graph here, it shows the lifespan of a Docker container. All right, by minutes. I don't know what the thing down here is, but this is really helpful. This helped me understand how to use containers properly. The average lifespan of a Docker container is like less than a minute. It's like super short. Because these are designed to run a singular process. So people will use these to do some quick processing, to run scripts, to run different things. They do their job and they exit. So a mass majority of these things run for a very short amount of time. And if we need to do it again, if we need to do the process again, or we need to do some more processing, we spin up more containers. Instead of having one long-lived thing that processes a lot, we just shoot off containers that might not live very long. Containers lifespan can be pretty darn short. Okay, that's helpful to know when you are building these things, to kind of understand how to approach building them. When we ran that Ubuntu command, it executed this command, bin bash, which receives an exit code. It completes and it exits out of that thing. We can get it to run longer in a detached head state. So we can do a -d here, and we can do another Docker PS, and it still doesn't work how you thought it was going to work. Okay, we did it with Nginx, and it ran in the background. The reason why that detached head state didn't work is it did detach. It actually did detach, but the process still finished. That bin bash still exits. Okay, it still exits, and correct, it is because there's no TTY to connect to. You got it, Abyss. That's the reason why. Pick OOP, thank you so much for the 5 gifted subs. That's love right there. Congratulations to everyone who received one. Please thank your gifter. Thank you so much for committing to the war on advertisements here on this channel. Thank you so much for the love and the support. You're just helping us all learn a little bit more about Docker. Dope, absolutely, I really appreciate that. So if you have a command echo thing, the bash command is over and over and the container exits. Yeah, so it does what it's supposed to do. If you had it to echo thing, yes, it will in fact exit. Okay, but that is a useful thing. So check. You know what we're gonna do? Well, we'll do this at the end. The reason why, because Bash has no teletype device to connect to, it does its job and then it ends. If we want this to work, here's the little cheat I'm giving you now. Not even a cheat, but something to remember is if you want to do your best to run a container in the background, but you want to be able to interact with it. ITD is what you're going to want. There's a bunch of flags here. I'm just giving you some quick ones really quick. ITD means you can run it in interactive mode, which is going to allow you to interact with it. T tells your computer to give this container a TTY device. It allows your keyboard to actually connect to the container. All right, so interactive mode, a TTY device, and D is in detached state mode. So if I do this, I will now get a long running container. Okay, if I do a Docker PS, there is an Ubuntu container here, and I can actually log into it. Okay, I can actually do a Docker exec -it, which is the interactive mode. I actually might even need to do that because I did the ITD. And actually I could have done this in the exec command rather than the other one, but all good. And I tell it what I want to connect to, which is, Princess Schwartz. And whoops, sorry. And I got to give it a command to do. Exec, it stands for execute. So I can execute a Linux command here. So let's say I didn't even want to do, let's say I didn't want to do bin bash. Let's say I just want to see what's in this directory. I can do an ls-l, And this initiates an LS on this container, not on my host machines, right on that container. But if I want to log in, the way that I log into a container is not logging in, it is executing a shell against it. So I just type in /bin/bash, and this, now you can see the host name changed. I am now in this container. So if I were to do a PS or a PS AUWX like I normally do, look at this. The only thing that's happening here, the only, if I were to do, look, if I do a PS AUWX on this computer, look at this, PS AUWX, whoops. Look at all these processes. There's so many processes running on a host machine, but look at a container. These are all the processes running on this container. That is how small and light they are. Okay, it doesn't need to run all the extra stuff because your host machine's already running that stuff. So it's just, it makes it super nice. I didn't need to execute another bin bash against it. I could have just done it in one command, whatever. But I wanted to show you that ITD because it's pretty helpful. I can exit out of this and see that this is still running. Helpful, great. All right, some other things. How can you get information about the running container? Well, you can do a Docker inspect. Docker inspect on what's priceless. Actually, let's just do Swartz, and it will give you JSON information about what's going on here with this container. Actually, apt install JQ. Let's get some JQ going just so we can have some sweet colors. Sticks Racing, welcome to the channel. Lock, welcome to the channel. Makeshift, welcome as well. Good to have you here. All right, so let's pipe that to JQ really quick. If you don't know what JQ is simply it is a JSON, and it's a JSON parser, and it helps you see some cool things. But you can get all the information that you want about a container using the inspect command. If you want to know what status it is and what command is running and when it was started, it's just a good way to grab some information. Just showing you how to get some information back if you want to get some information back from this thing and to see what's going on. You can see networks, all kinds of other stuff, IP addresses, all kinds of stuff, because each of these will get its own internal IP address for this stuff. 3060 Ti in the US, I want to say that it's like 450. I mean, well, yeah, aftermarket, pretty crazy. What's today? 3 days, you can get a 3060 that has more VRAM than 3060 Ti. Pretty crazy, isn't it? And the 3070 and the 3080. It's got more VRAM. It's got 12 gigs of VRAM. 1250 is a lot. Okay, so we have this running great, very, very exciting. Now, let me give you something more useful. Let's go back to the Nginx container. Let's stop that container really quick. All right. Good. Let's run an Nginx container so that it's an actual useful piece of technology for us. Docker, run Nginx. Or let's do -d Nginx. Okay, that's great, phenomenal. That's what we did before. That will run an Nginx container, but this will run an isolated container. The way that we can remove that isolation is to do something called port mapping, and this is the first way. This is the way that you can create channels to get data out of a container or to create connections from a container to the host machine. And so the way that I'm gonna do that is with a -p. All right. And then you can, with the -p option, you can map a container on the container. You can map a port that runs on the container to a port on the host machine. So if I'm gonna do port 80, port 80. What this does is this maps port 80 on the host machine to port 80 in the container. So I could actually map port 80 to whatever port on the host machine I wanted, and vice versa. So if you were trying to run, we talked about this before, someone said, could you run Apache and Nginx on the same server? No, because ports, not by default, because ports can only be consumed by one process at once. Once something's running on port 80, nothing else can run on port 80. Nothing else will be able to start on port 80. But if you wanted to run them both, you could run one on port 80 and map it to port 80, and you can map one to port 81 on something else using a container, because those things are isolated. So -P will give us the 80 and the 80. And if I hit enter here and I go back, so now we can see our ports. It's showing this is my network interface here, and it's just saying 0.0.0.0 port 80 is mapped to port 80. And now if I go back to here, it's probably gonna be up already, and I refresh it, it now works. Because when we're requesting this data, the data is coming in over the IP address, and because port 80 is listening through this container, the data goes into that container, which is running Nginx. Nginx responds, kicks it back out. Super helpful. Yes, port 80 it's the host. So if I stop this, so look at this, I can run another one on port 8001. Okay. So if I change that, now if I go here, if I go back to the thing here, I'm running 2 different versions of Nginx, and I'm running on port 80 and port 8001. And look at that, it works just fine. And you might say, oh, is that working? If I go to port 8002, it's gonna fail. You can see it spinning, it's gonna fail. And if we wanna run it again, you know, I can run it on port 8002 as well. This is also another good showing that off of one image, off of this one Nginx image, we've just deployed 3 different containers, listening on different ports. So now it's working on 8002. Okay, we now have 3 completely separate containers serving Nginx over 3 different ports on the host machine, because we were able to do that. You can also run it again if I don't want to specify the port. I think you can do a -P, a -P. What this will do, if you do this, this will expose whatever exposed ports in the container are available. It will expose them to a random port, okay? So now it exposed it to 49.153. This can be helpful in development situations. This can be helpful in a number of different places, but you don't have to be specific about what you want. But now it gave me 49.153. And now if I were to go look at that, it would give us that, okay? Joker 404, welcome to the channel. Vitamin C, good to have you. Idiocracy, good to have you as well. Slayer, welcome. Good to see you all here. Oh, so Abyss, I never remember which one is which. The only reason I knew which one was which is because MC said yes to the previous question, to Burning JC's question. I never, ever remember. Absolutely, it's definitely about finishing time. I'm gonna show you one more thing. We're gonna, so now you can see how they run. Now you can see how containers run. So we saw how you can stop them. So I'm gonna docker stop, let's see, what's the best way to do this? What can I do? Docker stop, do I have to eval this? Whoops, not eval. Whoops. I can never remember, how do I, no, it's $, right? How do I stop all of them? I don't remember. I want to stop them all at once. See, I haven't managed individual Docker containers in a long time. Oh, do I do the whole thing? Aquafung, nope, running. Yeah, I'm running on this on Lingo VPS. Yep. Oh, there we go. Docker, always did Docker PS. Oh yeah, there we go. That makes sense. Was that the only problem? That was the only problem? That's helpful. Oh, I just did PS-A. Thank you. Okay. There we go. See, you know, super kind of helpful. Hold on. Yeah, there we go. That was interesting. I don't know why it. Okay, cool. Whatever. So I stopped them all. Another thing is that you can. Another quick thing. We're gonna learn a lot more about this on Wednesday. Another quick thing is that they're all stopped right now. I can remove those as well. Oh, actually, so I stopped them. The way that you remove them is I can run that same command, and I can do docker rm. that will remove those containers. And now if I do a Docker PSA, there's nothing there. So you can remove them, which is helpful. Real quick, we're gonna write our first Docker file. Super easy to do. Do I have Vim one here? Yeah, I do. Real quick, let's create a Docker file, which simply, we're gonna write a Docker file that just has a script that echoes out some information, okay? Here's all we're gonna do. We're gonna make a Docker file, okay? And the first thing that's going to be at the very top is a from statement. This from statement is going to give it, if you want to use, well, it's going to give it a base image to base everything off of, to pull from and base everything off of. You can do Alpine, you can do a bunch of stuff, make it super easy. Just to make it easy, I'm going to do an Ubuntu 20.04. We're actually going to go over, we're going to build a pretty extensive Docker file next time on Wednesday, so don't sweat it. But from Ubuntu 20.04, we're gonna base our whole image off of this. So it's gonna pull that image to base everything off of. This is where those layers come in, and it comes out very helpful. So from there, we're gonna do this. What we're gonna do is we're gonna do, what's the first thing that you do when you set up an OS, even though this isn't an OS? Let's run a Linux command. So we're gonna do a run statement here. And all we're gonna do is apt update, and now we're just gonna update. We're gonna make sure that we're all up to date. We don't really need to, but this is going to allow us, the run command allows us to run some Linux commands in here. And so we're gonna update it first. Then we're gonna do this. Here's what we're gonna do. We're gonna run echo. In the top of the file, we're gonna make a script here. /bin/bash. We're gonna echo this into, actually, no, check this out. Let's do it. Let's be very verbose. We're gonna create a file. We're gonna create a file in /root/startup.sh. All right, /touch. We're gonna touch this. Touch creates an empty file. So the first thing that we're gonna do is update. Then we are going to create an empty file. Then we're gonna echo some stuff into there, okay? So we're just simply running some Linux commands. So we'll echo that, and we will ampersands, and let's echo. All our script is going to do is it's going to echo. We did it. We built and ran a container. What is the problem here? Put that in here. That should work, and we'll put that in the same file. And I could have just done the same thing, but I just wanted to show you some cool stuff. Let's see if this works. Startup.sh. Cool. So now that that's there, we now have a script that should be able to run, but we need to make it runnable. So we're going to chmod it. Chmod plus x /root/startup.sh. All right. And then the CMD, the command that we are going to issue to this, is going to be, /root. We're gonna run this file. The startup command that we're gonna run is this. I can't remember. Does this need to be a string? I think it does need to be a string. And so this is gonna be the thing that gets executed when this container starts, okay? All right, so I just thrust you into the creation of a Docker file. This is not good Docker file creation at all. Each of these commands, each of these main keywords is going to execute a different layer. So that kind of sucks. You kind of want to layer as much together as you can layer together, but I could just kind of want to get it started. I just want to kind of get it running from here. So let's, I don't think I need these. I don't think I need these quotes, do I? I'll leave it there. Let's see what happens. So we have this Docker file. I actually have no idea if the syntax is going to be correct on that command statement, but we'll see in a second. But let's build it. The way that you build it, use single quotes maybe, we'll see. Docker build is how you're going to do that. So Docker build. And you could just build, you could build this file. I could do a Docker build and then just do a dot and tell it what to build, what Docker file to build. You saw that I called Docker file with a capital D. That's all you need for the name of the Docker file. Kind of as opposed to every other file you probably ever made, the extension is actually the first part of it, and not the dot, what comes after the dot. Because usually, like, you know, a Python file is a .py file. Docker files will all be called Docker file, and if you wanted to differentiate them, you call it like dockerfile.nginx if you wanted to. Great, whatever. But I'll do Docker build -t. -t allows you to give it a tag. Okay, so I'm gonna call it, I'm simply gonna call this I'm gonna call it our Nginx. Our Nginx is what I'm gonna call it, because we just did it. And I'm gonna have to put a dot. It says build it, the Docker file is right here, so build it from right here. And I got an echo, I got a problem here on line 8. Oh, is this the wrong slash? This is the wrong slash. There we go. All right, so now during the build process, take a look at this. Step 1 from Ubuntu. So it pulls this image first to kind of get started with. The next step is just simply running the commands that we wrote. It's just a script. It ain't that special. And it's going through and it ran an apt update. Then step 3, it ran the touch command and it completed successfully. And it created, these are all creating different layers. Okay, step 4, it ran the next run command that I put in there. Step 5, it ran through all the steps. Look, it set everything up. It created all of these different layers. Okay, I'm gonna show you something cool in a second. All right, so now it's up. Now it's here. If I do a Docker images, take a look. Our Nginx is right here. Made 39 seconds ago. It is 100 megabytes, a little bit bigger than Ubuntu 20.04. All right, so now let's go ahead and try to run it. Even though I don't know why we called it our Nginx, I forgot it's not an Nginx container. And look at that. It ran the process that we created, okay? We created a script that was just going to echo something out, all right? All it did was it was gonna spit out some stuff to standard output. When we ran this container, it successfully ran. It ran the script that we wanted it to run. Let's look back at what it's supposed to be. The entry point to this, the command which ran was root startup.sh. We executed this script, a script that we created right here. We created a script right here that just, all the script did was echo out a command here. All right, all it did was echo out a simple command. The container did its job. We could run that as many times as we want, and it will execute the same thing. If we do a Docker PS, it's done running. But if we do a Docker PS-A, you can see here it ran, it exited, but this is the command that it started up with, okay? And it ran what it was supposed to run. So imagine if you have some type of processing script, some type of thing that you run on the daily, you could do this in a container format pretty easily. Now, like I said, it does get more complicated when you have to have something that is long running, long lived. You have to take into account a few different things. And we'll talk about that a little bit more on Wednesday, but yeah. So why couldn't we create an Ubuntu container and install Nginx on it? We could do that too. So actually, let's do that real quick. I'm gonna show you some caveats. I'm gonna show you some problems. All right. So if we were to instead, let's actually delete all this. Let's say apt update and apt install Nginx. We could do that 100%. And what's the command to make Nginx run? What command do you want me to use to make Nginx run? How will we start Nginx? Maybe you want to do service Nginx start. Maybe you want to do that. All right, maybe that's the command we're executing. Is that what we want to do? So this actually has to change because of the way that this command needs to be put in. I think it has to be in array like this. So command Nginx start. I'm going to save this. I'm going to build it. Are you want to do systemctl? For systemctl, which comes first? System control. Was it systemctl start Nginx? All right, so C inside start. All right, so I'm gonna build this. I'm gonna rebuild this image, okay? So it's gonna start all over, and it's going to run the app update, and it's gonna install Nginx. And okay, it failed. So this is something that you need to be aware of whenever you are installing packages using a package manager inside of a Docker container, is that you must throw this -y on there because you cannot interact with it at build time. You can't interact with it. So usually when you're trying to install something, it says, hey, are you sure you want to install something? We can't interact with it, so pass on the -y if you want to get that going. And so we'll have it build again. Update, yeah, update probably. Update doesn't need a -y. I think I just put it there out of habit. Out of poor habit, I just threw it in there. Cool. So now we successfully built this thing, and now it's a completely different image than it was before. And let's say we ran our Nginx, and it is supposed to be Nginx. So let's give it a -p, and let's also give it a -d. Okay, so that we can run it in the background, and let's run it. First, it says, hey, start a container, systemctl, executable, not found in path. This is one of the first pieces that makes this tough, because this is not an Ubuntu operating system, okay? If I were to spin up, I'm gonna spin up an Ubuntu operating system, and I'm going to exec into it really quick. I actually don't have access to, I don't have access to system control. Okay, I don't have access to a lot of different things. I don't have access to a lot of different tools that you might be available, that you might be used to. Why? Because this is not an Ubuntu operating system. It is simply a collection of extra packages that Ubuntu feels like you would find useful if you were to utilize this thing. Okay, so systemd is probably not even, it's probably not in here at all. Or if it is, it might have to be called by full path, but I doubt it's even in here at all. So maybe we could call, I think you can call Nginx by name. Okay, Nginx not found. What can I do? Service. Okay, I have service. So service is available to me. Service is available. So let's do this. Let's change this really quick. Let's change our command. And I'll change it back to what it was. I'll change it back to this. And if I do a build, whoops, I didn't mean to do that. I'm going to do a build. Notice how, check that out. Notice how it didn't do the apt update anymore. It used the cache data. Nothing here changed. So it didn't run all that again. The build took a lot less time because all we changed, the only thing that we changed was step 3. That's why layers are so good. You can cache data, you can keep it around. It's super duper easy. I mean, it helps a lot. So now if I rerun this command, it does run. If I do a Docker PS, it is not up though. If I do a Docker PS -a, service Nginx start, that command runs. That command did execute, okay? Service Nginx start returns an error code. It returns a status. It comes back with a 0 exit code, okay? And because it comes back with a 0 exit code, and it tells us right here that as far as the container knows, that is done. That is ready to go. It's like, hey, you did what you're supposed to do. We're exiting now. So it's not quite as easy to just install Nginx and get it running. That is why if you go back and you look, yeah, so you can do some stuff like that. You can probably redirect. You probably can do some fancy redirect operations to like do some weird stuff to keep it up and running. There's a lot of different things that people do to keep containers up and running, but most services and most things have paradigms for this. Nginx in particular has a way to run this as a daemon. So let me go back to, and actually we built one before, but is the Docker file here? Probably not. So let me go back to Nginx. But Nginx allows you to daemonize it by default. And I think the command that you have to pass in, let's look at what they have. As you can look in here and see what their command is. And here it is, Nginx-G daemon off. So if we take this command, all right, we take this command right here and we put it in ours. Okay, this is Nginx-G daemon off is the command to do this. And if we save it and we build it and we run it, if I do a Docker PS, look at that. I have 3 now and it's running with this and it's on port. Oh, actually, okay. So another reason why, okay. So it didn't actually map any ports. The reason why I didn't map any ports is because our image does not tell it that it has to expose a port. The way that we expose a port real quick, just so we make this work all the way, right now it won't work. We have to expose a port and we're gonna tell it to just expose port 80 and we'll build that. So all it was is just this exposed line right here saying, hey, go ahead and expose port 80 for us. And so now that gets built into the packaged up version of this thing. And I'll rebuild it. And if we run this again, it should be 4 here now. So now there's a 4.1, and now on 49.154, this is serving, and this is the one that we built, 49.154. It's running. This is the one that we built. This is not the official Nginx image. We built this image right here. So you can build your own pretty easily. You can see ours has a lot less code than the other Nginx one. But yeah, you know, let's see how big it is though. And ours is 159, whereas the main Nginx one was 133. So ours is a little bit larger. So it is what it is. Okay. You go bail for dinner? Yeah, we're bailing now too, Abyss. Thanks so much for coming through. Yep, we're bailing right now. So there we go. That is your quick introduction into Docker and to containers. All right. On Wednesday, we will dive into building deeper. We're going to dive into building Docker files a little bit better. We're also going to start talking about a couple other things. We're going to start doing multi-container applications. How do you connect Docker containers together so that they can communicate with each other? Also, we might dive into Docker Compose if we have time. So we'll build images. We'll learn about that. We'll also learn about how you handle data and how you handle persistent storage. We said storage wasn't persistent. So for applications that need that, how do you handle the persistence of your data and storage? Yeah, we'll have a little bit of fun. So can you do something like in that Docker run -- entry point bin sh it alpine to keep the container running? Yeah, so you don't need, using the -- entry point, probably you can. I would usually pass in, so I usually do it like this. If I want to do a Docker run -itd, let's say I want to do alpine, which is, alpine, and I would pass it in as a command, but we can pass it as an entry point. And if I do, well, okay, so alpine doesn't have, bin sh, yeah, doesn't have bash by default. That will work. And so now I should have an alpine container running. That will work. See, the command and the entry point are different, but can be utilized in a similar way. You should be able to use -- entry point, Dorian, to work just fine the same way that I just did this. I just chose to pass it in as a command rather than an entry point. And so I downloaded it, and it does keep it running. Yes, you can execute a shell to be able to keep it up and running if, and only if, you are running it in detached and attach it to a TTY. If I didn't do the it would still run, but I wouldn't be able to interact with it, I don't think. So yeah, you can absolutely do that. So with Docker Hub, something like that, pre-built, Grommet. Oh yeah, tons of different pre-built things in there that you can go through and look on how to use. Tons of different things. Gary's Mod server is from Docker Hub. That's dope. I haven't played Gary's Mod in a really long time. What's up, Zeno? Welcome to the channel. P2 Pass, welcome. Lead Monkey, good to see you as well. Jihad, welcome. I joke. I kid. Good to see you, Jake. I think I got everyone else. Underrated. Welcome, SDK. Welcome, Slick. Yeah, so we're gonna talk about data. We're gonna talk about data persistence and stuff all on Wednesday. Yeah, I'm about to get out of here, and I got a little pre-dinner, so I'm not super hungry right now, but I do have some work to do. Got to go. We're getting the house together. We're almost in the we're almost in the any day now phase. Yes, wow. So we are, it's a little bit more scary. Not scary, but we're trying to get the house and everything together for the pending baby, because we're delivering at home. So gotta have everything ready. We're doing a home birth. So that's what I've been, nightly on the weekends. I've been trying to use my time to do that, get the house together, as well as do my work to keep my business running. It's all dope. So yeah, come on through back on Wednesday if you want to learn a little bit more about that. If you're in Decoded, this week we are going to basically be doing a big project. Well, not big project. We're going to be building a project in Decoded for the entire week. So yeah, that should be fun. So if you're interested in that, come back through tomorrow. We'll start building something. We're gonna be, I'm not gonna tell you what it is yet because it's still up in the air between two different things. I have two different things created. I want to figure out what we can finish in 2 days. It's been hard. It's hard to try to figure out a project that's perfectly sized for something like this and to get all the stuff in here. Thank you. Please, I appreciate that. Plasma orbs. Thank you. Oh, dope. That's dope. So it's even better because, a lot of the hospitals and stuff, wouldn't necessarily allow me to be there if there was going to be, they allow one person, and maybe if my wife had her doula or whoever, or the birthing assistant or whatever, I wouldn't be able to, I might not be able to be a part of it in a hospital. Like I wasn't able to go to the first ultrasound and stuff. I had to kind of watch from my phone and stuff. It kind of sucked. I feel bad for a lot of my friends are having babies right now as well, and I kind of feel bad for everyone who may not get to be as big of a part of it as they would like to be. But yeah, our first one, maybe delivered through DoorDash. Hey, I mean, if they can deliver, I'm with it. Whoever can deliver successfully, I'm with it. Big Leaf, absolutely. Cool, yeah, we're out here. Let's see, who are we gonna go over and raid this evening? I ain't got some work to do. Whoa, that's loud. Who's on? Who can we go say hello to this evening? Bobby, you always want to go over to Danny Stem. Let's give some other people some love. I was hanging out with Danny on Danny Stem's channel the other day. Was it earlier today or yesterday? I saw you on there. She does do some fun stuff on there. Let's see who we got. Cyber insecurity. Is cyber insecurity on? I said we were going to do cyber insecurity because someone else called them out last time. Yeah, let's head over to cyber insecurity if you're interested in some cyber security stuff. LinkedIn hacking, that sounds kind of cool. I might have to stick around for a while for that, but yeah. Absolutely, Keith. Appreciate that. I really do. Let's go over and let's raid cyber. Come on, spell it right. Cyber _insecurities. LinkedIn hacking. I don't know what that means, but I want to know. Also, who's that who just gave me a follow? What's up, Sigfo Drum? Welcome as well. Good to see you, Two Ugly Crocs as well. Peace out, everybody. We're gonna get out of here in 10-9. Nope, invalid username. We are not gonna get out of here in 10-9-8-7. Okay, we're gonna type it in correctly this time. Cyber _ it's cyber insecurity and not cyber insecurities. Insecurity. All right, here we go. What's up, Chelsea Bites? How are you doing today? It's good to see you. It's really good to see you. Hold on. Let me cancel that real quick. First off, let me give a shout out to Chelsea Bites. If you want, so like I said, there are a lot of smart people here on, a lot of very smart people here on Twitch. If you are looking for someone who is not only super intelligent, but also will have you having a good time, have some good conversations with, you know, you don't always want to sit around and go over Docker files and stuff. Please give Chelsea Bytes a follow. I'm so serious about that. We're gonna, please give Chelsea Bytes a follow. It's good to see you. Thank you so much for coming through. I do appreciate that. Now we're actually gonna go over and raid cybersecurity. So I have so much work to do. I'm kind of sad right now. I kind of want to stick around, but let's see if they can teach me how to, you know, I want to hack LinkedIn. I definitely want to hack LinkedIn. Security. There we go. I said earlier, I'm gonna send this tutorial series to my husband's coworker. Hey, you know, hey, Chelsea Bytes. We are about to do, in March, we are gonna do a 6-part Docker series. So this is just a 1-week thing to end off this boot camp. What we're gonna do, it's gonna come out soon. It's called Contained. It's 6 parts. I'll definitely share some information about it pretty soon, but it will run in March along with a couple other shorter things. Git, Linux, a couple other ones as well. So if you're interested, cool. But yes, the stream is ending now. We're heading over to cybersecurity. I will see you all later. Peace out.